Today in lesson 19, you went from equations to inequalities. So I'm going to show you just a glimpse of what we did in class today. The first thing we did is a build of lessons 17 and 18. We worked on solving equations, okay? So I'm going to separate the equation into two equal sides. My goal is to get my variable by itself, okay? I know that I can undo addition of 6 by subtraction of 6. Whatever I do to one side, I must do to the other. So I'm left with my variable y equals 10. And I know I can check this by substituting my solution back in for y. 10 plus 6 indeed equals 16. And now I'm going to work on plotting that. I'm going to put 10 in the middle of my number line, and I'm going to count down, then I'm going to count up. And since y equals 10, I'm going to put a point on 10, and I'm going to shade it in, because that dot means that 10 is the solution for this equation, okay? This question is also asking me to choose from the numbers in this set that would make each statement true. That's what we did in lesson 16. There is no 10 in my set, so there are no solutions or none that make the equation true. Notice here that equations only have one correct solution. Okay, you can solve inequalities, which is what B is because it has the greater than symbol, the same way that you solve equations. I'm going to draw a line down the middle. My goal is still to get the variable by itself. I'm going to undo addition with subtraction. Plus 6 minus 6 is a value of 0, and they cancel. Whatever I do to one side, I must do to the other. This solution is different. Y can be greater than 10. So I'm again going to number my number line. I always start with the solution in the middle. And I'm going to put a dot or a point, I'm going to use the right vocabulary. I'm going to put a point on 10, and I'm going to think about whether I should color it in or not, okay? Y is greater than 10. So the solutions that will make this inequality true have to be larger than 10. Doesn't have an equal to 10. Therefore, I'm going to leave this point open, okay? I am going to shade all of the numbers on my number line that are greater than 10. 11, 12, 13, 14, and 15. And I'm also going to shade this arrow. It's very important, okay? This tells us that the answers or solutions could go on and on and on to infinity, okay? Inequalities are different from equations. Since equations only have one correct solution, inequalities have an infinite amount, okay? So this last one of this series, I'm going to draw a line down separating the inequality into two sides. I'm going to undo addition with subtraction, and whatever I do to one side, I must do to the other. Y is greater than or equal to 10. Okay? Oh, thank you for watching this video as I number my number lines. It's a good skill to have. Okay, I'm also going to put a circle on 10. Now I have to think about whether I shade it in or leave it open. Look at your inequality. Y has to be greater than or equal to 10. Since it can equal 10, just like our equation, I'm going to color it in because 10 is a correct solution. Now I'm going to shade to the right. Look at how your inequality sign tells you which way to shade. And these are all of the numbers greater than 10, and there's an infinite amount of them, so I'm going to shade the arrow. And I can't believe I forgot such an important step in B and C. Okay, I'm going to go back to B. I have to choose the numbers from the set that make this inequality true. So Y has to be greater than 10. So I'm going to look at my set, and I'm going to pick the numbers that are greater than 10. They are 11, 12, and 15. For this one, I have to pick the numbers in the set that are greater to or equal to 10. And there's no 10 in my set. So the answer to this one is still going to be 11, 12, and 15. I'm going to do 3 more examples with you, okay? So again, I'm going to draw a line to separate the equation into two equal sides. I'm going to expand multiplication with a dot to remind myself that it's multiplication indeed. To undo multiplication, I'm going to divide this side by 3. 3 divided by 3 is 1. 1 times g is just 1g. And whatever you do to one side of an equation, you must do to the other. So in this answer, g equals 5. So I'm going to put 5 in the middle of my number line. I'm going to put a point on it. I'm indeed going to shade it because g equals 5. There is no shading to the left or right here of this point because g can only equal 5. Out of the numbers in the set that we were given, the only number that makes the equation true is 5. Let's try a less than inequality. 3 times g is less than 15. I undo multiplication again with division. Whatever I do to one side, I must do to the other. G has to be less than 5. So this is 5, 4, 3, 2, 1, 0, 6, 7, 8, 9, 10. I'm going to put an open point on 5 and I'm going to pause to reflect, okay? G is going to be less than 5. That doesn't mean it can equal 5. So I'm going to leave my point open. And this inequality tells me to shade to the left, okay? Just like this arrow right here. See how this sign matches this one. Okay, so I'm going to shade all of these this way. And I'm going to check, are all of these numbers less than 5? Yes, they are. Okay, the numbers in my set that make the inequality true are all of the ones less than 5. They include 0, 1, and 4. 5 cannot be a member of this set. Last one. We can do it. 3 times g is less than or equal to 15. So I'm again going to undo multiplication with division. Whatever I do to one side, I must do to the other. Our g is less than or equal to 5. Point on 5, should I shade it? I should, because it can include 5 in its solution. And again, I'm going to shade to the left where my signs match, okay? And I'm going to now change my answer from the numbers in the set. We have to, g can be anything that's less than or equal to 5. So solutions can be 0, 1, 4, and 5. Good luck with your homework, and I hope you try some of these on your own with your educator.